Hello. Today we're going to look at writing two-step equations. This is lesson 3 in chapter 2 of our math books. And we're going to go ahead and head to page 130. On page 130, we're going to look at how we can translate sentences into equations. So as we're looking here, we can see that we know that words describe a situation, using only the most important words if we're really looking to give a simple and complete sentence or statement. So what we're going to do is we're going to look at words, define the variables and or numbers and the operations that are used within the words in order to write an equation. So we're basically looking at how we take words and we think about the variables to create an equation. So let's look at example 1. Translate each sentence into an equation. So we have the words, 8 less than 3 times a number is negative 23. Now, the first piece that I'm going to look at is this 8 is less than. Now, if 8 is less than, I know that we're talking about subtraction, and 8 is less than something that is greater. And so we can think about that something as having to be that initial starting point. So 8 is less than 3 times the number. So what they're telling me in the second part is what 8 is less than. So it's the something that I was looking at. 8 is less than 3 times a number. So now we know that we had started with 3 times a number, and we're going to do 8 less than 3 times that number is, and we know that is our word for the symbol equal, negative 23. And so we can see here, well, there's the equation, but now we've kind of talked through that idea behind it. So let's go ahead and look at example 2. I'm going to go ahead and erase that so I can have some space to define what we're reading about. In this next one, 13 is 7 more than 1/5 of a number. The first thing we're going to want to do is read that sentence and then read it again and begin to look for words that are going to help you to build that equation. So let's read it again. 13, so we have our 13, is so we know that is means equals, right? So 13 is 7 more than. Now again, it's important to look at that more than, just like the less than that we looked up here, tells us that it's more than something, and that something has to come first. So 13 is 7 more than something, right? Well, let's think about that. Now they're going to tell us what that something is. 7 more than 1/5 of a number. So now I've defined my something as 1/5 of, and what does of mean? Of is going to mean to multiply. So we're going to multiply 1/5 of a number. We don't know the number. When that number is unknown, we can choose any variable. A lot of times you're going to see the letter N being used to replace the word number. So here we have 13 is 7 more than 1/5 of a number. Okay, let's try the next ones and see how they look. Letter A. Okay, well, letter A says 15 equals 3 more than 6 times a number. Again, I'm going to read it a second time, and now I'm going to begin to look for words that are going to help me. 15, let's think about that. 15 equals. So I'm going to go ahead and I'm going to rewrite it here. 15 equals 3 more than. So that more than tells me that the 3 is going to come as the second term. 3 more than. It is more than something. Well, that something had to be the initial piece of this conversation. It's 3 more than 6 times a number. So that something has to come first. 6 times a number plus 3 is the same as saying 3 more than 6 times a number. Okay, wonderful. Let's look at the next one. Now, these are definitely ideas that might cause you confusion, but just remember, the more you read and the more you practice, the better you're going to feel about what it is you're doing. Let's look at letter B. Letter B says 10 increased by the quotient of a number and 6 is 5. Okay, there's a lot of words there. Let's go back and take some of what we know to help us think about this. Now we know 10, okay, but because I don't know the rest of it, I'm actually going to go ahead and hold off on, I don't know, maybe it comes first, maybe it does come second. Not too sure yet. Let's go ahead and take a look. 10 increased, so we're going to do some addition. 10 is increased by the quotient of a number. So quotient, we know, is division. And when we divide, we're going to think about what is the whole amount and how many parts are we dividing it into. So we have 10 is increased. So 10 is going to get larger by the quotient of a number and 6. And then we know our is equal to 5. So here's the thing. Don't get frustrated by the inside pieces, the inside words. Begin with what we know. We know 10 is increased. And we know that it's going to end up being the same as 5. Now we can begin to look at 10 is increased by the quotient, right? The answer to a division problem when you have a number and 6, that number is dividing by 6. We can write this in 2 ways. I can say 10 plus n divided by 6 equals 5. I may also choose that I could do 10 plus. I'm going to put my parentheses just because I'd like to see how this term is connected and it equals 5. Now, do we need the parentheses? No, right? We really don't need it because order of operation would tell me to do division first, but it's not going to hurt for you to be able to kind of look and think about that division problem within the context of the question. So now let's look at C. So I'm going to go ahead and erase all my green. Thought it was just a nice, fun, bright color, not black or red that we're always seeing. Let's try C. What color? Take a guess. I'm going to go the nice mauve. Okay. Let's read C. The difference between 12 and 2/3 of a number is 18. Okay, let's read it again. The difference between, okay, the difference, I know the difference is the answer to a subtraction problem. Now, what it's between, let's see, well, the difference between something and something else, that would be our subtraction problem. So I'm just going to build the structure. The difference between 12 and 2/3 of a number is 18. Now here's the part where I would imagine we might make mistakes. We might say, well, I know that it's 12 because it says the difference between 12 and, but it's not only 2/3. It is 2/3 of, so I'm going to have to multiply that by a number. 2/3 of a number. So I'm going to say 2/3 times n is 18. So I'm going to come over here. I'm going to rewrite it. For C, the difference between 12 and 2/3 of a number is 18. Okay. These will take practice, so don't feel that just hearing this for the first time that you're going to be able to master this. If you're feeling confident, awesome. We are going to be moving on. So in your book, if you're following along with me, you see we're on page 131. Now they're giving us some examples, so you can take some time to read through these, but let's take a look. Number 3 says, you buy 3 books that each cost the same amount and a magazine, all for $55.99. You know the magazine costs $1.99. How much does each book cost? Okay, so the words, what do we know? We know that we want to purchase 3 books and a magazine. That and tells you that you are combining the cost of the 2 different things, books and magazines. And that total cost is $55.99. Now, here's where a lot of people can get confused. Let B represent the cost of one book, right? We don't know what each book costs. So I'm going to replace it with B. So I know that I'm going to have 3 books. So I can say 3 times B, right? Or 3B. Remember, I have a book plus a book plus a book. I can take these 3 variables and I can simplify them to 3 times B because addition and multiplication are so closely related. So I'm going to look at 3B plus $1.99 because that's my magazine that I know is my total of $55.99. Okay, if you follow through here, we've set up our equation and we are going to go through our 2-step process of, we're going to step 1, remove the constant from both sides. Step 2, I see that there was multiplication, so I'm going to divide. That leaves me with B as isolated on the left side, and it equals 18. Therefore, each book cost $18, and you can see that I am defining the 18 as dollars by adding in my dollar symbol. Let's go on to number 4. A personal trainer buys a weight bench for $500 and W weights for $24.99. Now, are those weights W weights Or are they telling us that we don't know how many weights they purchased, right? We don't know how many, but each one weight, 1W, I know is $24.99. That's super expensive. Now the total cost of the purchase comes out to $849.86. How many weights were purchased? Okay, well, so that makes sense, right? I know one weight is $24.99. I know that there's a workbench, the weight bench, that was $500. And I now have defined my W. That the variable represents each of the weights. I don't know how many there are, but I know that $24.99 is one W. So what if it was two weights? Well, you'd multiply by 2, right? W would become the number of weights. So we can see here that our equation is the bench at 500 plus $24.99 times W equals my total of $849.86. Now you can follow along here with the equation is written, and now I follow my two-step solving equation process. I subtract my constant on both sides. I divide by $24.99 on both sides to isolate W, and I can see that the trainer purchased 14 weights. Now, it's a word problem, so you have to define your answer and let me know that you know what does 14 represent. We're going to try this problem on our own. Let's see if you got it. Here we go. The current temperature is 54 degrees Fahrenheit. It is expected to raise 2.5 degrees Fahrenheit each hour. In how many hours will the temperature be 84 degrees Fahrenheit? I know that I have a starting point, and then I know that there is an increase to get to my new temperature. That starting point, 54 degrees Fahrenheit, and we know it's going to rise. Now what's interesting is it's going to rise 2.5 degrees Fahrenheit each hour. But because we don't know how many hours, we can say, well, H will represent the number of hours. Each time an hour passes, 2.5 degrees increases onto our temperature of 54. So if I have 2.5 degrees Fahrenheit for 1 hour, 1H, but maybe I want to look at 5H or 6H, then I'm able to use a variable, because remember, the variable means that that number can vary. And I want to figure out how many hours until I get my new temperature of 84 degrees. And I'm going to do my work over here. I have 54 plus 2 5/10 hours. Now, just a side note, I know I was saying a half because we know that 2 5/10 is 2 5/10, and 5/10 is the same as 2 1/2. So just that reminder of how our decimals and our fractions are related. Okay, so we're almost done. Stick with me. We have 54 plus 2.5 hours. I want to figure out how many hours until I hit 84 degrees Fahrenheit. I'm going to follow my two-step solving of equations. I'm going to subtract my constant on both sides. 54 divided by 54 is 0, leaving me with 2 5/10 hours equals 84 minus 54 is 30. I need to divide 2.5 or 2 5/10 on both sides. to figure out how many hours. Now, for a lot of you, I know you might just say, okay, I'm going to go ahead and I'm going to plug this in to a calculator. But let's review long division. I mean, because who doesn't love doing that? 2 and 5/10. I'm going to make that 25 by multiplying that by 10. I'm going to make 30 into 300 by multiplying it by 10 by moving that decimal place. How many 25s are in 30? Well, there's one. 30 minus 25 is 5. I bring down that 0. How many 25s are in 50? And there's 2. So there we see that I have 12 hours in which my temperature is going to rise from 54 degrees to get to 84 degrees Fahrenheit. Okay, this is a wonderful resource to go back to. We were again looking at how to look at words, bring in variables to create an equation.